Hello, this is Mr. Collier, and today we're doing some logarithmic models. So here's a model for the height in meters of a runner bean plant. So the height is given as 0.25 plus log base 10 of 2t. Okay, so find the height after 4 weeks. Well, that's simply substituting in 4, and if we type that into your calculator, you get 1.15. Okay, we're going to have to graph it in a second, so actually you might as well graph it on your calculator and get that answer directly from your calculator. So let's go to apps function. Let's type in the function 0.25 plus log 2 times x. That's our model. And then we go to num, and we can check out, we can click the number 4, and it takes us to 4. So you can see h of 4 is 1.15. 1.15, and this is in meters. Okay, part B is the number of weeks it takes for the plant to reach 2 meters. So log looks like that. It's the inverse of an exponential, so it looks like that. We're trying to find when it reaches 2. So we're going to graph 2 and figure out when it reaches 2. So you can even scroll down to the table and see it's getting closer to 2. It takes a while. See, it actually looks better around like 28 point something. So if I go to shift plot, I can go from 0 to, I don't know how t is number of weeks. Let's try 30. I have no idea. But the y value is going to go up to, actually I do know, have an idea, but we just looked at it in the table. It was 28 point something. So the y values, we need to go up to at least 2, so I'm going to go to 3. And let's plot it, and did I plot the other thing yet? Nope, I have to plot 2. So I get a horizontal line across at 2, and there we go. We can see the point of intersection. Let's go to function, intersection, and 28.1, comma 2 is the point of intersection. 28.1, comma 2. So the answer is 28.1 weeks. So just after 28 weeks. Okay, next we have this magnitude earthquake releases this much energy. Find the magnitude of an earthquake which releases this much energy. Okay, so find M when we have this E value for energy. We could just type that into our calculator. We have 2/3. Oops, my calculator's a bit glitchy. So let me reboot my calculator. 2/3 times log 5.1 times 10 to the power of 10 divided by 10 to the power of 4.8. So just make sure everything's typed in correctly, and we get 3.94. Okay, that's 3.94. Second question, how much energy? So we're solving for E when the magnitude is 4.3. Okay, so let's do that on the calculator. Let's go to apps, function, and we can graph the function and find out when we get 4.3. Now, this was 3.9 for M, and this is a bit bigger, so I guess the energy is going to be larger. If we want to see the graph, we can go to shift plot and maybe type in maybe times 10 to the power of 11 or something like that. Okay, let's do 5 times 10 to the power of 11. That'll make it 10 times as big. Maybe that'll work. For the y value, we only need to go up to 4.3, so this should work. Let me go back to apps. We'll need to type in 4.3 to get that horizontal line going across 4.3 and plot, and then we can see the point of intersection. Okay, the intersection is that. So let's just draw a little sketch to show our work. The log goes like that. The horizontal line goes across there. The point of intersection is 177. Well, it's this number right here, right? 8279941 I probably shouldn't use commas there because it looks a bit confusing with the coordinates. But that number there is equal to 1.78 times 10 to the 11. So that is indeed the answer. Okay, so also musical notes are on a log scale as well. You can see a note which is twice the frequency of another is said to be 1 octave higher. Okay, so one C is an octave below the next C. A note n octaves above middle C has frequency f. The variables n and f are related by the equation n equals this here. Okay, so n is octaves above middle C. Octaves above middle C, and f is the frequency. So questions are going to be about n and f. Find the frequency of middle C. Well, n stands for number of octaves above middle C, so it's not above middle C at all, so this is n equals 0. Okay, so we plug in n equals 0 and solve for f. So 0 equals 3.322 log f over 261. Okay, so to solve that, we can graph this and find the root. There's other ways to do it, but that's a quick and easy way to do it. So 3.322 log x divided by 261.6. And let's delete that and plot. Can't see anything at the moment, so let's change this to 0. Okay, f is frequency, and I'm seeing some big numbers in the question, like in the thousands, so let me put in 10,000 and see what happens. Y is number of octaves, so I don't think that's going very high. Looks like you can have negative numbers actually. So -2 up to 5 maybe? I'm not sure how the musical notes work. Now we can see the graph. It looks like a normal log graph. How many octaves above middle C is this frequency here? Well, we can just do, we can substitute in f equals 784, right? Actually, I forgot to even answer the first question. Find the frequency here. We didn't actually get that yet. We had to get the x-intercept of this graph to answer part 1. So go to menu, function, root is the x-intercept, and it is 261.6. Okay, which is just this number right here, right? That makes sense because if you have this, you get log of 1, and log of 1 is 0. So let's go back to this one here. We want, basically we want n when f equals this. So we can go to num. You can actually type in 784, and it gives us the answer is 1.58. 1.58. Okay, next it asks us for find the frequency 3 octaves above and 1 octave below. Okay, so this is n equals 3, and the second one here is n equals 1. We can go to apps here and graph 3 and plot, and I can see the point of intersection. It is 2090 to 3 significant figures. Okay, by graphing it, you can see it is 2000, f equals 2090. And this is actually -1 because it's below middle C. So we can graph now -1 can see the point of intersection down there. Menu, function, intersection, 131. F equals 131. If you check out that graph, that's what we get. 131 comma -1.